Dr. K. Parinivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on environmental chemistry. We are discussing about water quality parameters. The previous lecture we discussed about the significance of various water quality parameters, and now we are going to discuss how to determine these parameters in water, the water sample, how we are going to analyze in this lecture. So, the water sample should be collected properly. If required, it should be refrigerated, stored properly with the appropriate preservation things, and then brought to the laboratory for the detailed analysis. Okay. Because we have wide variety of parameters, we have to test for physical parameters, chemical parameters, biological parameters, all those things. So, it is very important the water sample is collected with the utmost care and then brought to the laboratory to get a very reliable representative data of the particular sample. Coming to the analysis, we have different variety of analytical techniques related to the parameters analysis of water quality. Some of the parameters even we can go for classical wet chemical method of analysis, that is titration based one and gravimetric analysis. Titration using burette and pipette, very simple, gravimetry based on weighing. So, even this parameters can be used, certain parameters we can do it with the classical wet titration or gravimetric method, but other parameters require instrumental analysis support. For example, we can go for electrochemical measurement, for example, pH, electrical conductivity, and some other parameters also we can do it with electrochemical techniques. And the predominant one we have to rely upon the spectroscopic technique comprising of UV visible, atomic absorption spectrometry, atomic emission spectrometry. This is a spectroscopic technique is the one most heavily we depend upon water quality parameter determination, and we have to use for other parameters, especially for organic analysis we have to depend on mass spectrometry and chromatography techniques like gas chromatography, high performance liquid chromatography, as well as ion chromatography, both for organic and inorganic. And if we see the physical parameters, we can measure the odor just by nose, organoleptic, and similarly taste also, both by taste we can do that. But other parameters we have to rely upon other sources. For example, color, which appears the natural water color is slightly yellow and usually determined by what is called platinum cobalt scale using colorimetric methods, using UV visible spectrophotometer, which is normally represented in Hazen unit. Suppose we dissolve 1 milligram of platinum salt that is actually tinted with cobalt chloride, that gives exactly the similar yellow color resembling that of natural water. So, this is a one used for measuring water color, platinum cobalt Hazen unit. Normally, this is used for only naturally occurring color. This is a yellow color, but sometime industrial wastewater may appear different. We should not use this platinum cobalt, this should be used only for natural things. Turbidity, we can go for turbidimeter, using turbidimeter or nephrometer we can use this, and the standard used is silica, is 1 milligram of silica per liter. If you add, this is 1 NTU or 1 JTU, and nowadays Formazine standards also available in the market instead of silica based standard. And this turbidity, as I mentioned, it is a measure of scattering of particle, light scattering of turbidity. If you measure in the same angle, this is normally known as turbidity. And scattering, suppose if you measure it in the right angle direction, normally this is known as nephelometry, and these are the standard normally used for measuring Formazine based turbidity standard 555, 505, like this also. Okay. And with as I mentioned, turbidity, straight direction, if you measure the turbidity of the light scattered, that is a turbidity, right angle nephelometry, and usually nephelometry techniques are more sensitive. Even 0.1 milligram, 0.1 NTU can be determined with the nephelometry. So, more at least 10 times more sensitive than turbidity, the nephelometer. The other parameter routinely we measure as pH. pH, it is a neutral pH is 7, and sometimes we encountered acidic pH, alkaline pH also, okay, due to the presence of hydroxide, carbonate, bicarbonate, it may be appears alkaline, and due to the acidic impurities the water may be present as acidic also, below 7 also possible. The technique used for measuring pH is a electrometric method. It is a potential measurement using H plus ion sensitive electrode, that is a glass electrode in the laboratory. Even nowadays it is all available as a pen type, just like a pen, you can put it in a packet, go to the field and measure the pH with a pen type of pH meters. That type of improvement have taken place. You need not bring the laboratory with the water, you can go to the field, on field you can measure this, but always laboratory methods are more reliable, which works on pH meter, that is a glass electrode, calomel electrode, combined one. It should be calibrated frequently with a standard buffer like 4 or 7.2, 7 or 9.2, that should be calibrated frequently daily and used for thing. Apart from this pH meter, sometimes colorimetric methods also used with our dye indicators or paper. Color indicator papers are also available for measuring pH. That is all crude, but the reliable method is pH meter. And with the advancement of technology, nowadays portable instruments are available, and in fact it is a field instrument used for multi-probe analysis. With the 1 meter we can insert, as shown here, different probe simultaneously. You can measure all this. For example, there is a pH sensor with a glass electrode, and you have a DO-meter, dissolved oxygen meter, and turbidity meter. You have turbidity meter, pH sensor, okay, and temperature sensor. What is the temperature of the water body is also required, and conductivity sensor, or it can be used for solid measurement also. So, in a single things you can put all the 4 or 5 different sensor like dissolved oxygen, temperature, conductivity, pH, turbidity, and ORP also, oxidation reduction potential, also can be measured simultaneously with a multi-probe instrument on the field, because sometimes especially in the DO, dissolved oxygen, pH, turbidity, all this temperature, in fact it has to be measured on site. So, all these parameters including ORP has to be measured on site. So, this way this is considered to be very ideal for measurement of pollutants in water. Conductivity, as shown in this previous one, probe is available, and it actually measures the impurities of anions and cations present in the water body. Actually, if you put it and insert it, all the positive ions migrate towards the cathode, while the negative ions will attract to the anode, and because of this there is a current flow will happens upon the due to the applied potential, and the resistance of the solution is actually measured. That is, the resistance between the electrodes, anode and cathode, is measured as per the Ohm's law, and the conductivity measurement is based on the Ohm's law. That is, the applied potential is proportional to the current, that is the I value, and R resistance. Okay. This is Ohm's law. Based on this, we measure the conductivity of this, and the diagram is shown here. The electrochemical conductivity sensor, you have two platinum electrodes made up of platinum anode and cathode, and if insert it and apply a potential across this, there will be a resistance between these two, and the resistance is measured. That is the basis of electrical conductivity sensor. The advantages of this EC measurement, even though we do not have a standard value, most of the natural water, if you multiply this electrical conductivity value by factor of 0.68 or 0.7, approximately 0.7, that will give you immediately the total dissolved solids content, TDS value. You can get it within a minute, less than a minute, based on this EC value. Whereas, if we consider the total dissolved solid by gravimetric method, you have to collect water sample, evaporate it, cool it, desiccate it, and then weigh. It is a time consuming. At least 3 to 4 hours minimum required to get a total dissolved solid value, whereas EC measurement can give you the quick result within a minute. But only thing is, you have to establish a correlation between the EC and TDS. Once few experiments if you conducted measuring both EC and actual gravimetric TDS, that can be used to routinely monitor the TDS by measuring the EC value. Other chemical parameters, pH already we have checked, there is pH meter or indicator. Hardness is another one routinely we determine, and the simple method, wet chemical laboratory based method can be used, that is a titration. Simple burette and pipette can be used to measure what is the hardness, that is total hardness, what is present. By titration using EDTA, ethylene diamine tetraacetic acid, as a reagent, take it into burette, add indicator, and then find out this by hardness estimation. Chloride again can be done by titration using silver nitrate as a reagent. Here the method is called Morse method, and indicator used here is potassium chromate. Using potassium chromate, you can find out what is the chloride very easily. And residual chlorine, this can be again estimated by titration using iodine starch method. Titration, or sometimes nowadays color comparator also available. Chlorine, and especially in the wastewater treatment, will have a on spot measurement just by color comparator. Fluoride is another water quality parameter, very important, because in India it has caused many health related issue. Many people in many places of our state, different Indian states, are affected by the high level of fluoride concentration in drinking water, and the method used for determination of fluoride is ISE, ion selective electrode, similar to pH meter, where glass electrode is used. Here, instead of this glass electrode, you used to use a fluoride ion selective electrode. Usually this is made up of lanthanum based material, and lanthanum have an affinity for fluoride. Immediately there will be a potential difference between this solution and the electrode, ion selective electrode. The potential difference is measured. That is a quick method again, and one of the very well established ion selective electrode method for both pH and fluoride. And spectrophotometric colorimetric method also available. Using sparseness method, we can measure what is the amount of fluoride, but here the spectrophotometric method based on sparseness reagent, here actually it works in the inverse Beer's law. Beer's law normally will plot it by increasing the concentration. If you increase, generally the instrument reading or absorbance also will go up, whereas in this case it will be a reverse base of a reverse manner by following the Beer's law. If you increase the concentration, more bleaching of the colored dye and the intensity will decrease. So, the plot will be in a reverse direction. Solid determination, different thing. Conventional gravimetric is followed. The sample is collected and you evaporate the water and find out what is the weight gain ultimately with the help of crucible, that is normally known as total solid. It includes suspended solid, total dissolved solid, volatile solid and non-volatile solids, etc. And suppose you want to distinguish the fraction, you have to go for other method of doing it. After filtration with a glass fiber, if you filter and the clear water you evaporate and determine, and the other fraction evaporate of the filtrate if you do it, and that is the difference between total dissolved solids and total suspended solids. The clear water what comes in the filtrate, if you evaporate, the remaining amount is called TDS, whereas the whatever the part retained on the filter is called total suspended solids. So, the difference will give you the total suspended solid. So, from by measuring total solid and total dissolved solid, you can get what is the amount of total suspended solid. Further, suppose you, if anyone is interested in determining what are the inorganic and organic component of these material, okay, and put it in a muffle furnace, heat it at 650 degrees Celsius for about an hour, and in presence of oxygen, and if you determine what is the remaining weight out of it, you can get the different fraction, namely the weight remaining after evaporation is called fixed residue or inorganic solid content, and whatever the amount lost during the burning process usually represents the organic part or volatile part. So, by this way we can determine what is the total solid straight with the filtration, that is the clear liquid evaporate, you will get total dissolved solid, the difference will give you the total suspended solid, and these solids can be muffle furnace heated at with a muffle furnace. If you heat it at 650, the weight loss and weight remaining give you the inorganic and organic part, that is the residue is inorganic, non volatile, whatever the weight loss from the original thing is a organic part. The other parameters normally in water determined is dissolved oxygen 1, DO. This represents measured value represents a healthy water aquatic system, the DO should be greater than 4, and this is again determined by two methods. One is the probe method using DO probe, also potentiometric method, it is possible with the oxygen membrane, and another conventional titration method is a Winkler's method, in which manganese dioxide Mn2 plus manganese sulphate if we take in presence of alkaline medium, if dissolved oxygen is present, it will convert or oxidize the Mn2 plus to MnO2 manganese dioxide. This manganese dioxide is a very powerful oxidizing agent. In acid medium, it will oxidize iodine. If you add iodine, free iodine, I am sorry, potassium iodide, free iodide, the manganese dioxide will convert this iodide into iodine, which is a yellow colored solution. The yellow color may be titrated with thiosulfate, okay, or the concentration is low, add blue color and determine the, which will be the even very low concentration. So, thiosulfate will be oxidized to sulfate. Okay. So, this is called Winkler's method and can be used very easily, even it can be conducted in the low cost laboratory also by conventional method of titration. And the DO is again measured routinely, but this is also a base for BOD determination. Suppose someone wants to do it by BOD, the DO, initial DO is measured, and after 3 days or 5 days incubation, the final DO if you measure, that will give you the measure of BOD, biological oxygen demand. So, for that also the DO method serves as a important. So, the BOD determination in wastewater is one of the important parameters, again depends on DO, initial DO and DO measurement after 5 days of incubation at 20 or 3 days incubation at 3 days at 27 degrees Celsius. So, the organic matter determination, even though not done in wastewater, I am sorry, it is usually done in wastewater, not done in drinking water or surface water, but again indicates some kind of contamination. The water values should be very, very low if it is used for drinking purpose. The organic matter content can be determined by TOC, total organic carbon. It is an instrument based technique, TOC analyzer. BOD, we can do it by titration or a DO probe method. COD again titration by conducting chemical oxygen demand, potassium dichromate oxidation followed by its consumed dichromate concentration will give you the organic matter in water, but more importantly the COD BOD values are routinely determined in effluent, both sewage and industrial effluent, most common parameters BOD and COD. So, as I mentioned before, BOD represents actually the oxygen measures required for biological oxidation organic by microorganism during aerobic growth, initial and final DO, and it can be test can be conducted for 5 days or 3 days. More or less they will give you the similar value, close value 20 or 27. 27 is a quick method. If you compare to 5, we will get 3 days BOD. And for this test to be conducted, it requires a series of dilution to achieve suitable oxygen, because at the end of the 3rd day or 5th day some amount of oxygen should be available in the bottle for measurement, otherwise the entire experiments will be wasted after 3 days or 5 days. So, we have to be very careful. Normally series of dilution, at least 3 different dilutions should be made, and only partial degradation of organic matter as reported, and not complete degradation is possible during this time, and cannot be mass balance, you cannot do it for this organic matter. And very high and very low values also gives unreliable results. Values above 1000 or values below 10 usually give unreliable, and among the water quality parameters and wastewater quality parameters, most highly difficult to reproducible result is a BOD, very, very difficult to reproduce. And industrial wastewater can contain inhibitor sometime, leading to low BOD also. It will interfere with the analytical determination either by the DO by Winkler's method or DO probe method. COD again represents organic matter in industrial and sewage, and also measures the oxygen required, but for chemical oxidation of organic, whereas BOD oxygen required in presence of microorganism, whereas here a strong chemical oxidizing agents used to convert the organic matter into carbon dioxide. Usually the method test used is potassium dichromate in presence of sulfuric acid heated at 145 degrees Celsius for about 1 hour. Almost all the matters will be oxidized, and take potassium dichromate in excess. At the end of the digestion, there should be again the excess potassium dichromate should be present, and that is usually determined using FAS, ferrous ammonium sulphate, using ferroin indicator by titration, or spectrophotometrically also the color of the potassium dichromate can be measured spectrophotometrically also. And COD BOD combination tells you in many ways, many aspects of the organic industrial wastewater, where you can determine what type of treatment method is possible based on the COD BOD combination value. And always COD values will be higher, BOD values should be lower, never BOD overtakes the COD. This is almost gives you the complete theoretical, whereas BOD is always less, because partial degradation alone takes place in COD. And also we used to determine specific organics like polyaromatic hydrocarbons, pesticide, polychlorinated biphenyl, etc. in certain waters and wastewater we have to do it, and for this specialized techniques like gas chromatography or HPLC should be employed with the appropriate detectors and suitable columns for the separation of these different polyaromatic hydrocarbons and pesticide. We should use appropriate columns as well as a detector. For example, GC itself we have different detectors. Mostly if you want to estimate chlorinated pesticide, we have to go for electron capture detector. Suppose if it is PAH, you can go for flame ionization detector. So, like this, and HPLC also we have different detectors, UV visible, fluorescence, and nowadays mass spectrometry detectors are employed for this determination. Heavy metals determination and wastewater also, as well as drinking water also, we have a lot of parameters to be determined for this heavy metal, and we can go for spectrophotometric UV visible based on Beer-Lambert's law, which is a low cost technique, can be used for determination of these heavy metals also. And also we have advanced instrumental spectroscopic technique, namely atomic absorption or atomic emission, that is inductively coupled plasma atomic emission also available. Even in AAS we have different variety, flame AAS very low cost, and flameless AAS or graphite furnace AAS, and the sensitivity is better here compared to the flame, the sensitivity is good. Also we have specialized techniques like cold vapor technique for mercury and hydrate generation technique for arsenic, etc. available. So, depending on the what is the metal to be determined, we can go for, depending on the laboratory facility, low cost spectrophotometric method or advanced AAS or atomic emission could be used for their determination. And coming to application of UV visible, if you look at it, some of the water quality parameters also we can use, even though it is low cost. For example, phenol can be determined by 4-amino antipyrine method, spectrophotometric method could be used. Anionic detergents can be determined by methylene blue extraction. So, anionic detergents, phenol can be determined using low cost UV visible spectrophotometer. Inorganic contaminants like phosphate by molybdenum blue method or nitrate by azodite, one of the water quality parameter again, can be determined using spectrophotometer. Even speciation, chemical speciation of certain species could be done only by UV visible. The advanced AAS or atomic emission cannot give you information what are the species present. For example, ferric can be determined, ferrous ion can be determined with 1,10-phenolphthalein, and ferric with thiocyanate can be determined. Similarly, chromium 6 and chromium 3 can be determined. Chromium 6 can be determined only with the diphenyl carbazide, not chromium 3. So, after suitable conversion into hexavalent chromium, that can also be determined using diphenyl carbazide. So, in the simple low cost UV visible spectrophotometer or colorimeter could be used for chemical speciation of certain elements like iron and chromium, etc. Even these heavy metal could be used for determination of heavy metal, toxic heavy metal by appropriate reagent by colorimeter. For example, arsenic, silver diethyl dithicarbamate can be determined at 1 microgram detection limit, which will absorb at 520 nanometer. By using the 520 wavelength, we can determine 1 nanogram of arsenic by silver diethyl dithicarbamate. Chromium diphenyl carbazide, 10 microgram can be determined. Nickel DMG, dimethyl clioxime, can be used, and cadmium dithiazone, copper neocarbon, antimony iodide, mercury dithiazone, lead again dithiazone. So, for different heavy metals we have different reagents, and you can see here all could be determined at very low concentration of in microgram range. So, these low cost colorimetric methods also handy in determining these type of toxic heavy metals in environmental samples. So, to sum up, to determine various water quality parameters, we have different type of analytical techniques. Even simple low cost wet chemical classical method like titometry, gravimetry, and simple instruments like electrochemical based pH meter, ion selective electrode probe also available, and advanced spectroscopy technique like spectrophotometer, atomic absorption, atomic emission for heavy metal analysis, as well as for toxic organic we have different variety of chromatography techniques to determine all these things. So, it is very important to know the water quality, what we drink is it fit for really drinking purpose or any other treatment is required to make it fit, that is very important. So, the determination of various water quality parameters is very important to determine the water is fit or any further treatment is needed.